Hello teacher, today we will present our project report on the topic classify plane by leaf characteristic. In this presentation, we will provide an overview of the problem, introduce the method application, discuss our experimental result, and share the conclusion as well as the potential application of the work. We hope that through this report, we can demonstrate not only our understanding of the project of the subject, but also our effort in applying knowledge to practical problems. In our presentation, we have four contents: overview and solution, system design, implementation result, and conclusion and development direction. Let's begin with the first part, overview and solution. Problem statement. Plane classification is an important task in research and application. However, modern methods are often time-consuming, require high expertise, and are prone to error. And nowadays, machine learning allows to build an automatic system to classify trees from leaf characteristics with high accuracy while reducing the workload for humans.
In machine learning, classification is one of the most fundamental and important tasks. It means what is to predict the class of an object based on input feature. There are many classification algorithms, but some of the most common one include is descendant tree, support vector machine learning, logistic regression, multi-class, KNN, and NABS. For our project, they decided to focus on their presentative ecosystem, logistic regression, multi-class, SVMs, and NABS by implementing and comparing the model with IMAX to gain a more comprehensive evaluation of the classification performance, particularly for large characteristic data. Second is system design. The tree classification process based on lab characteristic start with data collection, where images of leaves are taken from different angles and components. The data then goes through pre-processing to ensure consistency. IMAS converted to a common format, background, and removers, and normalization is applied for size and brightness. Next feature extraction in performance to capture the most relevant characteristic since these produce high dimensional data. Principal component analysis is used to reduce dimensionality, fuse the noise, and return essential information. The processed data is then used to change classification model, including SVM, NABS, and logistic regression. Finally, the changed model are evaluated using metrics such as accuracy, precision, recall for one score, confusion matrix, IOC, and ROC. The overall workflow is illustrated in the block diagram. So the sequence from data collection to pre-processing to feature extraction to dimensionality reduction to model training and to testing and evolution.
Next part is implementation results. Based on the result in the data table, it can be seen that logistic regression achieved accuracy 0.772 with a good balance between precision 0.774 and recall 0.75. resulting in an F1 score of 0.742. Both AUC and ROC are above 0.93, showing strong class discrimination abilities. For SVM produced almost equivalent result with accuracy 0.762 and one scored 0.739 and AUC is 0.931. ROC is 0.93, confirming its reliabilities. Never-based performed significantly worse with only accuracy 0.446 and F1 score is 0.44, close to random prediction, although its AUC is 0.877. The overall performance doesn't meet the requirement. Through this result on all three data groups, left back, left front, and background, we can see a clear difference between the model. Logistic regression consistently achieved the highest accuracy from 92.91% to 96.91%, proving strong generalization ability table performance across data groups and making it the optimal choice for the left recognition test. On SVM, ranking second with table accuracy from 86.41% to 89.12%. Although lower than logistic regression, it still demonstrates good classification ability and can survive as an alternative for neighbor-based consistently producing low result from 41.14% to 57.41%, relieving its limitation and handling complete literature. This model is unsuitable for the problem across all three data groups. Performance logistics and SVM are good. Close together, AUC is 0.93, F1 is 0.474. Neighbor base is clearly weak. F1 is 0.44. The remote from the main high, meaning high ROC proof the classification model is good, but accuracy is not. Because of some cross-class error, acronym is Nepurus and Pyrrhus is the zebra. The Bartlinic NB data assumption is not suitable. Current factor cannot separate some summary classes. Next.
Conclusion and development direction. Conclusion. Logistic regression achieved the highest accurate, more 92% state across on datasheet to optimal model. SVM also performance while more 96% can be considered an alternative and non-biased were which 41% to 56% not subtable for complex layer feature. Logistic regression is defined and identified as the best model, ensuring both stability and high accuracy. Development direction. Expand datasheet, add more lab sample, diversify tree species, explore advanced model, random forest, gradient boosting, CNN, gradient descent, very and add extra feature. Combines, I may with morphological or environmental data like session. Practical, you build an automatic live recognition system for mobile web to education researcher, research manager. Thank you for listening.